Vitamin B2. Vitamin B2, otherwise called as riboflavin. Riboflavin has the molecular formula C17H20N4O6. It is a water-soluble thermostable vitamin. Riboflavin is a bright yellow powder showing green fluorescence. When exposed to light, riboflavin in sodium hydroxide solution forms mainly lumilactoflavin. Lumilactoflavin has the molecular formula C13H12N4O2. Lumilactoflavin on boiling with barium hydroxide solution is hydrolyzed to 1 molecule of urea and 1 molecule of the barium sulfate beta-ketocarboxylic acid. The nature of this acid is shown by the fact that on acidification of the barium salt to form the compound C11H12N2. This compound shows the properties of a lactam on vigorous hydrolysis by boiling with sodium hydroxide solution. It forms 1 molecule of glyoxylic acid and 1 molecule of the compound C9H14N2. This can be explained in this equation. Riboflavin on reaction with sodium hydroxide in the presence of light forms lumilactoflavin, which on treatment with barium hydroxide solution yields 1 molecule of urea and a compound 1 with the formula C12H12N2O3, which on acidification yields compound 2 with the molecular formula C11H12N2O. Compound 2 on treatment with sodium hydroxide solution yields 1 molecule of glyoxyl and the compound of 3 with the molecular formula C9H14N2. The structure of the compound 3 was elucidated as follows. It is an aromatic diamino compound. Then it was found that it gave a blue precipitate with ferric chloride, and since this reaction is characteristic of monomethyl orthophenylene diamine, it suggests that C9H14N2, that is the compound 3, contains the nucleus. This is the nucleus found in the compound 3. The molecular formula of this is C7H10N2. But molecular formula of the compound 3 is C9H4N2. There are 2 carbon and 4 hydrogen atoms to be accounted for. This can be done by assuming the presence of an ethyl group in the benzene ring or 2 methyl groups. The structure of C9H4N2 is confirmed by the synthesis carried out by Kuhn et al. Okay, we can confirm the structure of the compound 3 through the synthesis. We are taking this dimethyl benzene, which is on treatment with nitric acid, yields this compound, which on treatment with ethanolic ammonia yields this compound. This on treatment with tosyl chloride and dimethyl sulfate yields this compound. This on acidification followed by the reduction with hydrogen and with the metal palladium yields the compound 3. Therefore, the structure of compound 3 is this. The compound 3 can be synthesized from the compound 2, which is on treatment with sodium hydroxide. It yields the compound 3 and 1 molecule of glyoxyl. Therefore, the compound 2 must have the structure like this. The compound 2 can be prepared from the beta-ketocarboxylic acid C12H12N2O3 This compound 2 can be synthesized from the compound 1 as follows. This compound 1 on acidification yields the compound 2 with the elimination of 1 molecule of carbon dioxide. Since C12H12N2O3 and a molecule of urea are obtained from the lumilactoflavin, the compound 1 must be. This is the assumed structure for lumilactoflavin. This on treatment with barium hydroxide solution yields the 1 molecule of the compound 1 and 1 molecule of urea. This structure of lumilactoflavin has been confirmed by the synthesis. N-methyl-4,5-diamino orthosilane is condensed with alloxan hydrate in aqueous solution at 50 to 60 degrees Celsius. This compound on treatment with alloxan hydrate yields this lumilactoflavin. Next, we have to find out the side chain of riboflavin. Exposure of a neutral solution of a lactoflavin to light produces lumichrome. The lumichrome with the molecular formula C12H10N4O2. The structure of lumichrome is 6,7-dimethyl alloxazine. Alloxazine, isoalloxazine or isomers, they can be interconvertible. Thus, lumichrome is lumilactoflavin with a hydrogen atom instead of a methyl group at position 9. This suggests that riboflavin contains a side chain attached to N9. The Zier-Witinoff procedure shows that riboflavin contains 5 active hydrogen atoms. Thus, the molecule contains 4 hydroxyl groups, supported by the fact that the silver salt of riboflavin forms a tetraacetate. Thus, the side chain is a tetrahydroxy derivative. And we have to account one more hydrogen, one active hydrogen atom in the hydrogen of the NH group at position 3. Since oxidation with lead tetraacetate produces formaldehyde, the side chain contains a terminal CH2OH group. The riboflavin forms diisopropyridine derivative. This indicates 2,1-glycol systems are present. So the proposed structure of riboflavin is this. This is the proposed structure for riboflavin. This side chain contains 3 chiral centers, and so there are 8 optically active forms possible. The synthesis of riboflavin by Kara et al. This dimethyl aniline treated with ribose on condensation and followed by reduction yields this compound. This on treatment with diazotized nitrobenzene yields this compound. This is reduced with Raney nickel under pressure yields this compound. This on condensation with in the presence of boric acid yields riboflavin. Thus, riboflavin is 6,7-dimethyl 9-D1-ribityl isoalloxazine. That's all about the structural elucidation of vitamin B2. Thank you, students.